So, hi everybody. I'm here to show you how do we use Bayesian network in L'Oréal in a very specific way, that is the microbiome. So I will first make a very quick introduction on L'Oréal, because I know that you certainly know the company. And I will introduce the microbiome and
no, I think we need to move them a little bit closer. Perhaps we can hold it up.
It's better?
A little bit higher, perhaps. I think that will fit.
It's okay now?
Yeah.
Yes. So, and I will introduce the microbiome and what is it in the first time, and why it is so popular now, and why L'Oréal is interested in the microbiome. I will show you in a second time how do we collect the data for microbiome analysis, and how do we use standard tools to analyze the data, and why Bayesia and Bayesian networks are very interesting for such analysis. And I will finish with a successful example using Bayesian network. So first, just a few key numbers about the company in which I work for 10 years now. The story of L'Oréal started in 1907 when a young French chemist named Eugène Schuller developed the first synthetic hair dye and called it L'Oréal. And in 1909 he founded L'Oréal, and 1 century later this is the first cosmetic company all over the world. There are 32 brands developed. You have some professional brands, some more consumer brands, some luxury brands, and some more dedicated brands to drugstores like La Roche-Posay. The company counts 83,000 collaborators, and around 4,000 are dedicated to the research and innovation. There are 7 centers all over the world to be close to the consumer and to capture their habits and use, and to be able to answer all their needs. L'Oréal is an expert in hair and skin, and delivered in different axes such as hygiene, skin care, skin aging, skin disorders, skin protection, and hair color for sure. L'Oréal has the first objective is to the research on innovation. The research on innovation has a first objective, that is to test the efficacy and the safety of the actives. And the first important thing is to better understand the clinical science, to better respond to the efficacy. So L'Oréal use very new technologies such as new generation sequencing for microbiome analysis, to better answer to the knowledge of the skin disorders. So just now I want to introduce the microbiome, just to tell you what is it in a global view. So the microbiome is all the organisms living on and in your body. There are a total count of 100,000 billions just in gut. So you can imagine all what you got on the body. And it has been estimated to 4.5 kilograms per people. So we have 4.5 bacteria on the body. A lot of people talk about an extension of the human genome. And some people talk about a full organ. 4.5 kilograms of bacteria must have a very big impact on the body system, for sure. So this is the first line of defense against external factors, such as pathogenic infections, and it specified a unique protective skin immune signature. The the microbiome is very different from one side to another. You don't have the same microbiome on the skin or in the gut, but a lot of studies have been conducted and have shown that the microbiome is very stable. That means that if you do several analyses, you will always find the same results with a little variability for sure, but you will find the same results over the time. So it's quite interesting for statistical analysis. Now I just wanted to explain why microbiome has such an interest today. This is for sure thanks to the evolution of the biotechnology, and specifically for microbiome, the sequencing methods are 100 times faster than before, so that makes possible to explore the microbiome. Microbiome is metagenome analysis, because we look at all the genome of all the bacteria. So this is still little known, but a lot of work has been initiated, and especially in the US. I don't remember the exact number, but a large amount of dollars were dedicated to the research for the microbiome. And its popularity is growing because a lot of causal links have already been evoked or even demonstrated between the microbiome and such lots of diseases, such as the Crohn's disease, the diabetes, the obesity, the eating disorders, and even the depression. I don't know if you've ever heard about, but a lot of people talk about the second brain for the gut, because there are a lot of links between the gut and the brain. This is very interesting, and it has led to some cure. For example, the Clostridium infection, which is a very bad infection. We didn't have any solution, can be cured now thanks to a transplantation of microbiome. In the same family, you can transplant microbiome to another people, and it has cured some people, so it's a very good news. So the microbiome offers undeniable opportunities for knowledge and innovation, and L'Oréal is very interested in investigating in the skin and scalp microbiome. In fact, it could be used as a biological target, and it could help to better understand the links between the microbiome and the skin disorders. It could help to characterize the skin disorders, and eventually it could offer solutions such as prebiotics. You give foods to the bacteria. Probiotics, you add bacteria on the skin, or bacteriophages that are bacterial virus. So you can directly target on a specific bacteria, and so you can correct the microbiome. So it offers undeniable opportunities for L'Oréal also. So now I think it was important to show how do we collect the data. Here just a picture of the different steps from the skin to the computer. So you start with the cotton stem. You get the DNA on the skin, on a specific side of the skin, with the cotton stem, and you put it in a swab. And after you fold all the swabs, and you transfer it to an analysis center where there is several steps. The first one is the extraction of the DNA. And after you have to amplify the DNA, but for the metagenome, you just amplify in a specific region which is present only on bacteria and not on human people. So you separate the two DNA. And this region is also specific to each bacteria, so that's why we can distinguish all the bacteria that are present on the surface of the skin. Once you did that, after you have the sequencing step, the sequencing step consists in classifying all the sequences you have into classes that are similar with a level of 97%, so very similar sequences. And when you have your classes, you can map them with public databases and associate the name of the bacteria if this bacteria is already known. Otherwise, you don't have the name, but so we are not interested in for the moment. So at the end, you have a matrix like that, with all your samples in line and all your bacteria in columns. And in each piece, you have the count, so we can know how many bacteria there are in each samples. So it results often in very large matrix, because in study we can find several hundreds of bacteria. So it's a very large matrix, so it's not so easy to interpret. So we have different tools, standards, very used in publications to summarize all those data. You will always hear about the alpha diversity, which is an index that takes into account the richness and the evenness of the population. So good alpha diversity is a diversity composed of many species and well balanced. When you are infected, you will always find a bacteria overexpressed, and it is not good. So a good alpha diversity is a high alpha diversity. In the same time, you have the beta diversity, which is a similarity measure, and this diversity.
Let me answer.
So we have the alpha diversity and the beta diversity, which is more a similarity measure that takes into account the phylogenetic tree that represents the kinship links between all the organisms. So it's more about the different bacteria you have, not the richness and the evenness, but more about the composition of the microbiome. So it's a second point of view for the diversity. So those two indicators are really interesting, and helps you to say if you have the same or different microbiome between different types. So you are happy because you can say, yes, the diversity is different in this type as compared to this type, but you don't have any explanation. You don't know which are the really bad guys, and you can't correlate all those information with the skin disorders and all things that can characterize a state. So we decided to use different methods to do this, and we selected the Bayesian network and the partial least square discriminant analysis in the first time to have the two complementary methods. The PLS is a very well-known methodology in the data scientist community, so that's why we decided to select it. And it uses linear components to summarize all the parameters, and it's easy to visualize on the pie plot. So for the interpretation, it sounds very good. And but the limitation is that this method is a linear method and doesn't fit very well with our parameters, which are more categorical data and count data. So we decided to use also Bayesian networks because it's a probabilistic graphical model And it's non-parametric. It's a discrete approach, so totally complementary to the linear approach. And the unsupervised mode helps to represent all the links between all the parameters we get. And the supervised mode helps to discriminate the different type and to select the better parameters to discriminate and characterize the different type we are investigating. I will show you now a successful example that we've done in L'Oréal. It's about the recovery of the sensitive skin after arc cleansing. This study has been conducted to better understand the perception of the consumer about the sensitivity of the skin. It's a really difficult sensation to characterize because even if the consumer says that he has a sensitive skin, we don't really understand what is beyond this sensation. So we decided to perform this study to better understand the really consumer perception, and so we performed it on 80 females, aged from 30 to 50 years old. They were all healthy. And those 80 females were divided into 3 groups. The type 1 for very sensitive skin, the type 2 for moderately sensitive skin, and the type 2 for slightly to non-sensitive skin. These types were defined by the consumer themselves. And as we know that we could have a very low dynamic between those 3 types. We are in cosmetic, we don't work on hard disorders, so we decided to look at the recovery of the skin after hard cleansing. So we collect several information at different times, before the cleaning, after the cleaning, and 3 hours and 6 hours after the cleaning. And we collected some self-assessment questionnaire, some clinical evaluation made by dermatologists, some instrumental data like the pH and the corneometry, which is an hydration measurement, and microbiome collection. So at each time we have all those information. So we first calculated the 2 diversity. And as you can see on the graph, there is a different recovery between the 3 skin types. You can see that just after wash, the 3 skin types have lost around 1 point of diversity, so quite the same comportment behavior for the 3 skin types after wash. But if you look at 3 hours, you can see that the type 1 is still at the same level as just after wash. Type 1 is the most sensitive skin, if you remember. And if you look at type 2 and 3, you see that they have started their recovery. And at 6 hours, type 1 starts its recovery when the 2 others are at the same level as before wash. And if you look now at the beta diversity, you can see that you have type 1 here, type 2 here, and type 3 here. And here you have after wash compared, the green dots are for before wash, and the blue dots are for after wash. And you have, so after wash, so before wash, 3 hours before wash, and 6 hours before wash. And you see that in type 1, the before wash and after wash dots are really separated, and still separated at 3 hours, and less separated at 6 hours. But if you look at type 2 and type 3, you see that the points are more, the dots are more superposed, and here also, and at 3 hours and 6 hours, it's also true. So what we conclude on the diversity is that there is no big differences just after wash, but the recovery is largely quicker, faster with type 2 and 3 skin types, so there is something different in the microbiome response. So we decided to, so we are happy, like just before, we are happy because we can say that the microbiome response is different between the type of skin. The big difference is between type 1 and type 2 and 3. But we don't know who are the bad guys, and we don't know what correlates with those specific bacteria. So we performed the Bayesian network. The parameters included in the Bayesian network were those ones. Some clinical evaluation, dryness and roughness, some demographic information about age, phototype, weight, age, and some instrumental measurement, corneal value, which is hydration measurement, the pH, and etc. We have a lot of self-assessment questionnaire, and we have set of first selected bacteria, because we had 700 of bacteria, so we decided to apply a first selection method, which is also specific to those types of data. So we retain only 30 bacteria. And now you can see the first network, which is a taboo order algorithm. We decided to fix the structural coefficient at 0.95 to have a larger information. And the first remarks are it was very appreciated by the specialists because they could see a lot of logic links. They were happy to see that the phototype was totally linked to the age spots, that each were totally linked to the usefulness of the skin. So logical links that made them confident with the methodology. A second remark is that we got lots of self-assessment questionnaire in the bottom left of the graphs, separated with all the bacteria and the chemical and instrumental measurement on the top right of the graph. So it has led to a first question. Does the self-assessment questionnaire answer well to the type of the skin? And after a quick investigation in BayesiaLab, thanks to frequency tables, we have quickly see that the correlation between the type and all those questions were less important than the correlation with the type and all those parameters. So it has led to a first hypothesis that the self-assessment questionnaire was perhaps not the good one to well understand the consumer perception. And it has been taken into account in new studies. Now we can focus on the taboo order algorithm results with a structural coefficient fixed at 1. And you can see that all the self-assessment questionnaire have disappeared. And we focus on the top of the graph now. And this graph was also interesting and really understandable by the specialists. Because, as you can see here, we have links between the pH value, the corneal value, the SAD, the tightness perceived by the consumer, and the dryness evaluated by the clinician. And all these parameters linked together made sense to the specialist. And it appears that perhaps the type of the skin, a sensitive skin, perhaps just tightness sensation for the consumer, and can be diagnosed by the dryness evaluated by the dermatologist. And the biggest parameters are the pH value and the Kernel value that explain exactly those type of sensations. We can see, we can just have a quick view of the probabilities, of the posterior probabilities, and you will see that when the pH is on the highest level, we have some bacteria that are that decrease, and we have the tightness that increase also, and we have the dryness that increase also. So all those hypotheses were in the good sense with the scientists. So it is really interesting for the scientists. And Stenotrophomonas and Leuconostoc are not very known, and it has opened new hypotheses, and the microbiologists want to investigate on those typical bacteria. It is the same information, but on Kernel value. We see that when we are at the lowest level of iteration, we have the Leuconostoc that increase, and at the opposite, the Stenotrophomonas that decrease. So this is very interesting for the microbiologist. And this goes in the same sense as dryness and tightness. So new hypothesis. And what was also very interesting is that we have found some groups of bacteria that have a similar comportment. If you look at these groups, you'll see that they are positively correlated with the type of the skin, so they are high when you are sensitive. And those bacteria have already been identified in atopic skin, so it makes sense. And they live in an ecosystem with a pH of 7.5, which is a very high pH. The pH of the skin is 5.5, so it's 2 points. Yes, and we also know that those bacteria are all motile and dislike oxygen, and they produce lactic acid. Sorry. So an hypothesis is that those bacteria certainly live under in a deeper yes, in the skin. So they will be perhaps hard to target, but we try to find some solution. And at the opposite, we have a group of bacteria that are negatively correlated with the type, and those bacteria have already been identified in normal skin, and they live in an ecosystem with a pH of 5.5, that is the pH of the skin. So all those groups made sense to the researchers, and this network has gained researchers' confidence, and it was really appreciated. We wanted also to discriminate the type and to find the best parameters to discriminate them. So we apply supervised network. We choose the children and wives. I don't know if it's the English term. To discriminate the skin types with structural coefficients equal to 1. We didn't want to select larger sets. Even if we don't have a lot of data, we choose this structural coefficient. And very interesting also because very slow set of parameters, but we find again the dryness, the value, the pH value, the Kernel value, and those three bacteria are still here to discriminate the type. So the first hypotheses are still okay. What was strange was to find those self-assessment questionnaire that was not in the first graph. And so we have investigated a little bit the network, and we have looked at the direct link with the type, and you can see that their weight are very slow, so not really important. But the fineness of the skin grain will be kept in the set of parameters because it makes sense also with sensitive skin. When you have a fine skin, you often perceive a sensitive sensation. Here it was just to show the posterior probabilities, and but it's okay. As before, you can see that Ctenotropomonas, Gentianobacterium, and which is Cupriavidus are three bacteria that are higher in the type 3 than in the type 2 or type 1. If we get back, all makes sense. The pH value, the pH value is at a normal state for the type 3 and increase with the type of the skin. The same for the corneal value, which decrease with the skin. So the network made sense to the researchers also, and it was good. So just to look at the power, at the prediction power. Here is the misclassification table after cross validation. We have only 90 people, so it was hard to make a learning set and a test set, so we decided to perform cross validation. And as you can see, the type 1 is quite well predicted with 82% of well classified, but the type 2 and 3 are less good classified, but perhaps it's about the small difference between those two types. So we decided to look at the performance when we merge the two second classes, and we see that the performance increased a little, and the results are quite good now. Bayesian networks were really useful to interpret the data. They show pertinent links between parameters. There is a large set of clinical evaluations that seem to be bad predictors of the sensitive perception, so it has been taken into account, as I said before. And in a future study, we will challenge the self-assessment questionnaire, and it's a really good first result. The consumer's sensitivity perception seems to be expressed by dryness and tightness, and correlated with the high pH and the low hydration. And some groups of bacteria have been identified and reinforced the hypothesis of the pH and the hydration. So what we retain of this network is that if we want to develop a product for sensitive skin, we have to find something that can control the pH and control and moisturize the skin. But perhaps we could also add some food for bacteria, like we've seen before, Stenotrophomonas, Gentianobacterium, etc. The supervised network was interesting because we highlight on 3 specific bacteria. The prediction power is quite good. It's quite good when we focus only on type 1 versus type 2 and 3. So those results have motivated two new studies that are in progress now. So we are very excited of analyzing those results. Those hypotheses were very interesting. So before communicating, we wanted to challenge a little bit conclusion. we decided to compare the result with the PLS DA. And here you have the biplots representation. And I've highlighted all the results, all the important results. So you can see that we find, again, the same bacteria, Cupriatus and Trophomonas. And we also find the corneometer, that is really important, and the pH value, which is at the opposite, that correlates with the type 1. So all the hypotheses shown in the Bayesian network were the same that in the PLSDA, so it was really comfortable for us. If we look at performances of the PLS, of the discriminant analysis, you can see that we are not better than with the Bayesian network. We have 87% of well classified in type 1 and about 60% in type 2 and 3. And when we merge the two together, we increase the level of type 2 and 3 to 79%. So the performance are quite the same as with the Bayesian network. So to conclude, the microbiome is a new axis that opens great opportunities for the knowledge and innovation. But as you've seen, it requires complex extraction with a large amount of data. So we have specific tools to summarize all this information, but they don't allow us to understand the mechanism. So we need a sensitive biological interpretation that requires a high level of visualization. That's why Bayesian networks offer a very good analytical and interactive solution because it is a non-linear method. The mutual information can be interpreted between numerical and categorical data. The results have been challenged with the standard method used in L'Oréal, and the conclusions are quite the same, so it's comfortable for us. It is very helpful for the researchers. They were really happy to play with the software, and the communication is simplified. And I think we'll use Bayesian networks in further study. And we know that we have a lot of things a lot of opportunities to increase the performance by using variable selections that are available with BayesiaLab, with latent variables, and use web simulator for the interpretation with the researchers. Thank you.